At this very moment, your body is holding a pool of corrosive liquid, powerful enough to dissolve metal. This is your stomach acid, and it spends every second of the day violently breaking down biological matter into the energy that keeps you alive. This internal digestion is the most personal example of a chemical conflict that occurs everywhere matter meets, a constant exchange of ions driving both the life in your cells and the machines in your cities. We define an acid by its hunger to react. They are sharp, sour, and turn blue litmus paper a warning shade of red because they are defined by a single act, flooding their environment with positively charged hydrogen ions. In the Bronsted-Lowry theory, acids are proton donors, shedding their own pieces to change the molecules around them. The Lewis theory looks even closer, defining them as structures that accept electron pairs to find stability. This microscopic instability has massive industrial utility. Sulfuric acid provides the raw reactive force inside batteries, allowing us to store and discharge electricity needed to start engines and power heavy transportation. Nitric acid operates on an even larger scale. It creates the mass fertilizers that keep global soil productive enough to feed billions. Because acids are highly reactive, they act as the primary instigators of chemical change, breaking down stable structures to fuel industrial growth and biological life. Every acid has its opposite, the base. These substances are bitter to the taste and turn red litmus blue. Instead of shedding hydrogen, they release hydroxyl ions that work to absorb and counteract acidic protons. When a base is highly soluble in water, like the sodium hydroxide used in heavy cleaning, it earns the specific title of an alkali. Bases drive the heavy production lines of the global economy. At this scale, alkaline solutions are used to break down wood fibers into the paper and synthetic fabrics that define our modern surroundings. These are the heavy defenders of chemistry. Their role is to meet the aggressive volatility of acids and force them into a state of balance. When acid and base finally meet, they don't destroy each other, they transform. Their extreme properties collide, merging into a perfectly stable chemical state. The result of this reaction is the creation of two of the most important substances on Earth, pure water and a chemical salt. These salts are the peacekeepers of the world. Calcium hypochlorite, known as bleaching powder, uses this stability to safely disinfect municipal water supplies, ensuring that the water in your tap is free of pathogens. Sodium chloride, common table salt, is used at an industrial scale every winter. Spreader trucks deploy thousands of tons of it across American highways to drop the freezing point of ice and keep roads open. In our hospitals, we use plaster of Paris for structural stabilization. This salt-based material sets into a rigid cast, holding fractured bones in place so the body can begin the work of healing. By forcing dangerous reactive elements into stable compounds, salts provide the reliable materials required for human health and infrastructure. We measure the intensity of this chemical conflict on a scale from 0 to 14. 0 represents battery acid levels of corrosive power, while 14 is the extreme of caustic drain cleaners. 7 is the exact center, the neutral piece of pure water. This isn't a linear scale, it's logarithmic. Every single point you move away from 7 represents a 10-fold increase in chemical intensity. Your own blood must stay within a razor-thin margin of 7.4 pH. If your internal balance shifts by even a fraction, your biological systems begin to fail. The pH scale is the literal boundary line between biological life and complete chemical dissolution. While nature seeks balance, human industry often needs the opposite. We use electrolysis to pump raw electricity into stable salts, forcibly tearing those chemical compounds back into their reactive components. This process uses a positive anode to drive oxidation and a negative cathode to force reduction. It is a violent electrical rejection of chemical stability. This forced separation is how we isolate and purify critical metals. Massive industrial cranes hoist pure sheets of copper out of electrolysis baths, providing the raw material for every electrical circuit on the planet. Human progress depends on our ability to override chemical peace, manufacturing the reactive power needed to build our civilization. These microscopic rules dictate the scale of our global infrastructure. From a single ion to an industrial processing facility, the mechanics remain the same. Every tool you touch and every breath you take is a product of this chemical conflict. You are a walking, breathing reaction, kept alive by the very forces that power our world. Now that you understand the war, you can master its rules. Welcome to the real world.